Hello friends, I'm Abhishek of Class 12 Science, and then today it's my second video in my YouTube channel called Abhishek Classes. So as I have already told you about my strategy, so today let's take up the chemistry part. Let's start a journey of my YouTube channel and your learning, or for many it would be the revision from organic chemistry. Since we know that the board exams are coming up from February 24th and it ends for PCMB students for in 16th March. So giving priority to class 12, let's take up the organic chemistry of class 12 and start a journey of haloalkanes and haloarenes, lecture number 1. Okay friends, so this is the notes, handwritten notes, which is more than enough, and give me some time, I'll try to create all the PDF ones, scanned ones, and I'll try to give it in the description box in few weeks. So let's start up with haloalkanes and haloarenes. So let's first have a basic idea of what is a haloalkane or what is a haloarene, and then let's move on with the chapter. So haloalkane, it is also called as alkyl halide. Alkyl halide means Rx. Okay, Rx, that is alkyl halide. So haloalkane or alkyl halide, what is that? Here the hydrogen atom is replaced by a halogen atom in an aliphatic hydrocarbon. So originally, example, we know that CH4. What is CH4? CH4 is methane. Right? Now, if we draw the structure of it, we will have hydrogen, hydrogen, hydrogen. Now, this is a aliphatic, right? Now, if we take out this one hydrogen and add halogen atom in place of this, so we will have CH3X. This is methyl halide, right? Methyl halide. Right, got it? Yes. So similar way, we know that this is sp3 hybridized. So for a sp3 hybridized carbon, if a halogen is replaced in place of hydrogen atom in aliphatic hydrocarbon, then it is called haloalkene or alkyl halide. The same case, the same type of example we can apply to haloarenes, right? So we can take up any example with respect to this only, the benzene derivatives. In that same story we have to continue. Replace the hydrogen atom with respect to the aromatic compounds with a halogen atom. So we know that in all the benzene structures, all the carbons are sp2 hybridized, all are double bonded, sp2 hybridized. So if we take out the hydrogen attached to that and if replaced by a halogen atom, then it's haloarenes, right? Cleared these 2 points? Yes. Now everything, it should have some uses, no? Like anything we are studying, it should not be like we are just studying and it has no application in our daily life. No, this haloalkanes, haloarenes, all the compounds of these have very much application. So if we talk of the applications which can be asked in Neet, as match the following or choose the correct ones, or in the box they'll give some examples and they'll check, say what are these, how much number of these compounds are haloalkanes, haloarenes derivatives like. So we have to remember the haloalkanes, haloarenes compounds are used as solvent for non-polar compounds, and we have to also remember the next example, that is chloramphenicol. It's an antibiotic used in the treatment of typhoid fever. And next we have to remember iodine. All the biology students should know this, that I think it's common sense. In iodine, it contains hormone thyroxine, in which the deficiency of this causes goiter. This is also a derivative of like organohalo compounds, and then synthetic halogen, vischloroquine. Vischloroquine is used for treating malaria. Halothane, used as anesthetic during surgery. And fully fluorinated compounds as blood potential substitutes in surgery. Right? So all these are organohalogen compounds. Right? So this is the introduction to the chapter haloalkanes, haloarenes. So are you all excited to move on with the nomenclature and the classification of haloalkanes and haloarenes? So basically it's very much simple. I can move a bit faster because I don't want to waste any of your time. It should not be like you all should feel boring, you have to skip the video. No. See, monohaloalkane, as the name indicates, mono, one, haloalkane. So this is a haloalkane, only one halogen atom, so monohaloalkane. Same two halogen compound, halogen attached, so dihaloalkane. Similar way with respect to taking out the alkane, if we keep a arene or a benzene or a phenyl, then same thing. If one halogen, monohaloarene, two halogen, dihaloarene, three trihaloarene, like that. Now, if we move on to the nomenclature part, what we have to remember. So first let's take up the haloalkanes. So the general formula for alkyl halides or haloalkanes is CnH2nX. So we know that alkane general formula is CnH2n plus 2. But here that one hydrogen is replaced by halogen. Because of that reason the general formula becomes CnH2n plus 1x. Okay. So basically I think primary, secondary and all these concepts are clear to you all in hydrocarbons and GOC, that is General Organic Chemistry of class 11th. I'll take up everything in detail, but now I'll give you all a general idea. So primary carbon means halogen or a functional group or all-time substituents, anything attached to the carbon. That carbon reference is attached to or bonded to still how many number of carbon atoms. Like see here, to be much clear with the example, see this is a halogen attached to a carbon. Now this carbon has valency 4, so all 4 are filled. Now a halogen. Now this carbon we have to take it as a reference. Now with respect to this, we have to check how many carbon atoms directly this carbon is attached. So this carbon, if we see all the other 2 bonds are attached to hydrogen, but here we have an alkyl group, so another carbon, so directly attached to 1 carbon. So primary directly attached to 2 carbon, secondary directly attached to 3 carbon, it's tertiary, right? Okay, so shall we move on to the next page? Okay, now this is a very important concept, allyl carbon. So generally the students get confused between allylic and vinylic. So allylic, if we talk about, see this is the carbon which you are taking into reference. So that carbon, the halogen attached to it, that halogen, with respect to that, halogen should be attached directly to the sp3 carbon atom, and that sp3 carbon atom directly attached to sp2 carbon atom. This is the order: sp3 halogen attached to sp3 carbon, sp3 carbon to sp2 carbon. This is and this carbon, because of that reason, is called allyl carbon. Same case with respect to haloarenes. So the halogen attached to sp3 in turn attached to sp2. So this is the allylic carbon, right? Any doubts? I think it would be clear. Now benzyl halide. In benzyl halide, the halogen is directly attached to sp3, in turn attached to sp2, which is a benzene ring. The same similar example. Now, vinylic. Here we have to remember the halogen is attached directly to sp2. See, this halogen attached to sp2, double bonded. Halogen attached to sp2. This is aliphatic, aromatic. Then, if you move on to what is aryl halide, the halogen attached to sp2, the in turn attached to that sp2 is particular aromatic ring. Here also it is a ring, but it's not aromatic because it does not follow Huckel's rule. 2n like that 2n plus 1 pi Huckel rule, that one. And then if you move on to aryl halide, the halogen atom attached to sp2, which is perfectly a aromatic ring, that is the benzene, right? This is a aryl halide. Then the nomenclature, I think this is the easiest of all. See, the first step in any compound they give, start numbering. Give the priority to the functional groups. See, here bromine is attached. Start from here. 1, 1, 2, 3. Right? So here 1, for one bromine attached. So 1 bromo, longest chain, 3 carbon. So 1 bromo propane. Right? Next. With respect to this has to be given lowest number. So start from here. If we start from here or from here, it like the numbering comes to same only. So let's consider one way. Right? So your second carbon chlorine is coming. So it will be 2 chloro. Our longest chain is 3 carbon. So 2 chloro propane. Similar way here, we have to start numbering priority. If methyl functional group of chlorine gets more priority with like with respect to this methyl functional group. So you have to start numbering here. 1, 2, 3. So 1 chloro, 2 methyl propane. Here for benzene, bromine attached, bromobenzene. For same bromobenzene, you have to remember this is para position, ortho position, meta position, para, meta, ortho. So here at the meta position, the bromine is attached. So we can also we have to start the numbering from here. 1, 2, 3, 4, 5, 6. So it will be like 1, 3 di 2 bromo. So 2 bromine are there. So 1, 3 dibromobenzene, or here it's meta. At meta, with respect to first position, we have to consider at meta the bromine is attached to meta dibromobenzene is the common name. 1, 3 dibromobenzene is the IUPAC name. Similar way, 1, 3, 5 tribromobenzene, right? Next. Here, this is, now try in the comment section, is this a chiral carbon? Is this carbon a chiral carbon? Comment it. I will not tell, comment it. And is it a secondary, primary or tertiary? Comment it. I will check and answer. Are you in a right? Is your answer right? Or if it's wrong, I'll bring up with that same concept a particular video, right? Okay. See, now here chlorine, already in the previous examples I have told you this gets a priority. So 1, 2, 3. So here at the second position we have 2 methyl groups attached. So as chlorine gets the more priority, it will be like 1 chloro, because for the first position the chlorine is attached, and at the second position we have 2 methyl groups attached. So it will be 2, 2, and it's 2 methyl. So that number 2 will not be used. We have to use the term di, tri, tetra. So it will be 1 chloro, 2, 2 dimethyl, longest chain is 3 carbon, so propane. So this nomenclature would be 1 chloro, 2, 2 dimethyl propane. This Very simple. So if you start numbering, at the second position only you will have the bromine attached. So it will be like at the second carbon, so it will be 2 bromo. The longest carbon is 3 carbon. So it will be 2 bromo propene. Okay. Now the last concept of the day is the geminal and vicinal dihalides. So geminal dihalides means the 2 halogen atoms are attached on the same carbon atom, right? Okay, so the general IUPAC name is dihaloalkane. So dihaloalkane is the general IUPAC name for both geminal and vicinal dihalide. So for geminal dihalide, the 2 halogen atoms are attached on the same carbon, and vicinal dihalide, they are attached on the adjacent carbon atom. And alkylidene halide is the common name for geminal dihalide. Vicinal dihalide means where the adjacent carbon atom, the halogen atoms are attached. The common name for vicinal dihalide is alkylene dihalide. Right? So this vicinal dihalides, the application of this you will get to know. Now if I just give a common, just general one example of a conversion, how to convert ethanoic acid to benzene. How will you all convert? Firstly, you have to convert it to alcohol, then you have to do dehydration, you will have alkene formed. Now for that alkene you have to do bromination. Then if you do the bromination, you will have a vicinal dihalide formed. There, very minute basic things you have to know in order to do those complex conversions, which is Neet or JE level. Right? So I think I'll just show you all the pages today what we have studied. We have studied the introduction, uses, all the classification, right? And also we have studied the nomenclature, right? Okay? Right. So, thank you all. Have a good day, right? And then in next video we'll come out with the general methods of preparation of haloalkane and nature of carbon halogen bond. Clear? Okay. So if you all are clear with the concept, then please do like, share and subscribe my YouTube channel Abhishek Classes. So thank you all. See you all. Bye.